Hello, in this video we're going to be continuing with the grid. So in the previous video we handled all the different touches. There's only one that I was actually concerned about, but the others are there so you can use them as you need to. We linked up all the touches, we initialized the grid array, we called the initialize methods, but we haven't implemented them yet. We'll be doing that very soon. We added our grid sprite, we added a background, and we added some definitions as well. So let's continue with initializing our grid rects and sprite. So we're going to do void game scene init grid rects, and in here we're going to initialize all the different rects. I've got the code right here because there's quite a bit here. I'll explain what's happening, and you can access all of this from our GitHub page as well. So that is fantastic. So this seems to be okay. It's just obviously the font size is pretty big. So let's show you what's happening. The second two, the third and fourth parameter is essentially used to set the size of our rect, and the first two are used to set the position of our rect in terms of where it's going to be starting from. And they obviously start from the first one, and as you go through them they move across the grid, because that grid that we added, that image, if we try and press it, it doesn't do anything. We know that there's 9 different grid spaces on there. We know that if we click the top left one, that we should do something with the top left one, but we need rects that are in the place of individual grid spaces to detect a particular touch event, and that's what all of this is for. So now what we're going to do is initialize the grid pieces, aka our sprites. So for that, just implement the method void game scene init grid pieces, and we're going to create a for loop and then another for loop inside of here. This is just going to allow us to loop over our grid pieces array. So we're going to make int x equals 0, x less than 3, and while x is being incremented every single time. Okay, don't need a semicolon there, my bad. Int y equals 0, y less than 3, with y also incrementing every single time. So now what we need to do is do grid pieces x y, and we're going to assign it to sprite colon create x underscore piece file path. You might be wondering, why are we assigning them to the x piece file path and not the naught file path? And the reason is we don't know which particular grid space will have a particular piece. Sounds obvious, yes. Also, we're not going to be displaying any of these at the moment. We'll be adding them as children to our layer, but we're going to set the opacity to 0. Then we'll animate when we actually press down on a particular grid space to set the visibility to 4. But before we do that, we'll change the image to the appropriate one. You might be thinking, okay, why assign an image at all initially? And the reason is because we want to set up all the initialization here. So that also includes the positioning. The positioning factors in the size of the grid piece. We can't factor in the size of the grid piece unless we know the size. That's the reason we are assigning a image to it, so we can get the exact size. So we're going to do grid, grid pieces x y set position, and for this, what we're going to be doing, this is some pretty darn cool stuff that we're going to be doing here. We are going to do a vec2. So vec2, we're going to do grid sprite get position x. So we're going to get the position of our grid. So where is get position? Get position, and it needs to be X. I'm going to add to it the calculation of grid pieces X, Y, get content size, aka the size of our particular grid piece, dot width, and this is going to be times by X minus 1, because if it's a 0, we want to move it to the left, because otherwise it's going to be in the center. And obviously if it's in the center, that's fine, and we'll be multiplying it by 0. And if it's one space to the right, aka the farmost right one, the one to the right from the middle, then it will add 1, because it'll be 2 minus 1. So now, once we've done this, what we need to do is do something very, very similar for Y. So we need to do grid sprite get position Y. Where is it? Y. We need to add that to the calculation of grid pieces X, Y, get content size, the height, times by Y minus 1, and make sure we get the right number of brackets. It is moaning about something, so what's it saying here? Expected expression. Okay, apparently it expects an expression. See what happens if I were to build it. Expected expression. So we're gonna have to go through this. And first of all, let's have a look. That looks fine to me. Expected. So we got vec2, grid sprite, get position X. We're adding that to grid pieces X and Y, get content size dot width. We're multiplying that by X minus 1. I just can't see why that doesn't like it at all. Not at all. So what I'm going to do, when I get something like this, I like putting in a text data like this, especially when I can see a lot more of it. And let's go over it and see what the issue is. Okay, apparently we have some sort of, was it extra invalid character? That was weird. So let's see if we paste that. That works. That was very weird. I would not have been able to figure that out in Xcode unless I rewrote that. Very weird, but it seems to be all good now. And now what we're going to do is, by default, set all the grid pieces to visibility is off. So set visible to false. We're also going to set the grid pieces opacity to 0, because we don't want it to be visible. Not only do we not want it to be visible, when it is visible, we're going to animate to make the opacity 100%. We will set this to 0 as well. Instead of doing it later on, we're going to do this, add child. We're going to add the pieces. By default, there's going to be pieces laid down. It's going to look like there's not, and that's what game development's all about. You'll have certain things that will provide illusions of things being there or not being there. As a result, it will feel and look different. That's what programming is all about, all of that magic. Now what we're going to do is check and place the piece. So void game scene, check and place piece. For this, we're going to use a touch parameter, and this needs to be a bit more than that. It's Cocos2d-x, and it's going to be called touch. We're going to create a rect which is going to equal to the grid sprite get bounding box. So this is essentially the size of our grid sprite, like aka each individual piece. And now what we're going to do is get the touch point. So this is where the user has touched. So touch get location. And now what we're going to do is iterate over our grid to see where we've clicked. So it's going to reuse this nested for loop like so. Now in here, what we're going to do is do if grid spaces x and y dot contains point. So if it contains a particular point, which is our touch point, then we obviously have clicked it, but we can't just place it right there. We need to check if that particular space of the grid array is equal to empty. If it is, fantastic. Now we can actually place our piece. So first of all, we're going to change the game state to state underscore placing piece. Now we're going to set grid array to equal to turn, so it will put either circle or X in the actual grid array, which keeps track of the individual pieces or spaces of our array. Now we're going to check whose current turn it is. So we're going to do if X underscore piece equals turn. We're going to do grid pieces Y set texture, and the texture we're going to set it to is going to be X underscore piece file path. Else, you can guess what we're going to do. Grid pieces X Y set texture equal to circle underscore file path. And now outside of this if statement, we want to set the piece to be visible. So set visible to true. Remember, we still won't be able to see it because the opacity is off. So what we're going to do, we could set the opacity to 100%, but we don't want to do that. We want to do grid pieces X, Y, run action. We're going to run a animation, and the animation is going to be consisting of a couple of things. So we're going to have a sequence, and the sequence is going to be a fade in animation, create, and the time is going to be the piece underscore fade in time definition that we created in the previous video. Then after the piece has been placed, we're going to call a function. Oh, not during, but after it has call func create, and call a method. Just do std bind, do ampersand game scene, because that's a scene that we are going to call a method from. We're going to check win. So every time a piece has been placed, we are going to check if somebody has won. So check win is going to be check win, and the way we actually pass in a parameter is slightly different. So you put the method, put in this X and Y, so this is what we're passing through, and we need to have another bracket here, and we're good. So we're running the action, so this will show our sprite now, and we have a couple more methods. First of all, we need to check if we've won. To do that, we do void game scene colon check win, and we'll put it int x, int y, and we're going to call the method check 3 pieces for match. So if 3 particular pieces have matched, remember in Tic-Tac-Toe or noughts and crosses, whatever you want to call it, there's 8 different win conditions: the 3 rows, the 3 columns, and the 2 diagonals. So I've already worked out these values, but you can essentially look at these and figure out which which 3 we are checking for. What I'm going to do is copy and paste an empty method. Remember, there's 8 checks that we need to do. That's 8 of them right there. And the next one is going to be 0, 1, 1, 1, 2, 1. Then we're going to have 0, 2, 1, 2, 2, 2. We're going to have 0, 0, 1, 0, 2, 1, 0, 1, 1, 1, 2. Now we're going to have 2, 0, 2, 1, 2, 2. And then the last 2 conditions are 0, 0, 1, 1, 2, 2. Now we need to do 0, 2, 1, 1, 2, and 0. Now we need to check whose current turn it is and switch. So we're going to do if x underscore piece equals turn, because obviously we don't want it to always be one particular piece's turn. We're going to do turn equals circle underscore piece, else turn equals x underscore piece. And now we're going to do if state underscore placing underscore piece equals game state. So if we're placing a piece, we can now set it to state equals plain. So game state equals state underscore plain, so we can play again. And now we're going to check if 3 particular pieces actually match. To do that, we're going to do void game scene check 3 pieces for match. Oops, daisy. And we are almost done with this part. Now to implement it, I'm going to check if turn equals grid array x1 y1, because the turn, aka the user, that's what we're checking for if it matches y1, and we need to check it for all 3 different grid spaces. So and we need to change this to x2, x2, x3, x3. Now we're going to do a string for the winning piece string, and you'll see what we're going to do in a second. First of all, we're going to check whose turn it is. So it's going to be 0 underscore piece equals turn. Double equals. And we're going to do winning piece string equals circle underscore winning piece file path, else the winning piece string equals x underscore winning. pop up. So that's the reason we have this particular variable. We'll be using that very, very soon. And now what we're going to do is create a sprite array of the winning pieces, which is going to be 3 winning pieces because that's how many you can have. We're going to do winning pieces 0 equals sprite. This is where we're going to use our sprite string, create winning pieces string, and we need to get a character string, so get C string. We need to do winning pieces set position. Sorry, my bad. We need to get the actual element, so set position. And for the position, we're going to do grid pieces x1, y1, and we're going to get the position. Pretty simple stuff. Now we're going to do winning pieces 0, set opacity to 0, because we're going to do an animation so it looks really cool. Trust me, you're going to love this. We're going to do this, add child, and the child we're going to add is, well, the one that we just created, so winning piece is 0. We need to do exactly the same for the other 2 pieces, so copy and paste this, change 0 to 1, 1, 1, 1, change this x1 to x2 and y2 position. Now this to 2, 2, 2, 2, and now this to x3 and y3 position. And now there's only 2 more things we need to do. First of those 2 is start fading in our winning piece. So winning pieces 0 run action, and the action we're going to run is a fade in colon create, and this is going to be piece fade in time. For the other winning pieces, we could have them fade in at the same time, but what we're going to do is have one fade in after another. It's going to look really cool. So for this, we need to run an action, but we need to run it as a sequence because we want to do it part way through our previous fade in. So we're going to create. The first one is going to be a delay time. If you can guess what that method or what that particular action does. And for this, we're going to do piece underscore fade time. We're not going to start fading in after the previous piece is faded in, halfway during that transition. And trust me, you're going to love this. This is going to look awesome. And then next we put a fade in, which is create, specify the time, so piece fade in time. And now we can copy and paste this. We need to change this to a 2, but instead of 0.5 we need to do 1.5, so it's not halfway through this, it's halfway through this because we've got a whole one as well added onto it. And now we simply do game state equals state underscore 1, and now we are now ready to compile this awesome application. So we are compiling it. Hopefully it all works. It's always that sort of fear when you've done quite a lot of code. Yay, that is working fantastico, which is fantastic. So it's just running our simulator, and we'll get our splash screen, then we'll go to our main menu, then we'll go to our beautiful, you know what, the ultimate game scene. And then once we are on our game scene, we'll test out our game. There's still quite a bit to go because we don't have any AI, we don't have anything to tell the user that the game is over, we don't have anything to handle pausing, and we haven't implemented achievements yet. All of that will be to come in separate videos. But for now, we're going to have this cool, awesome tic-tac-toe game. So let's see what we get. It's still running. Go to splash screen, go into our main menu, click, got our grid. So if I put a space here, as you can see, it fades in. Again, we've got no AI at the moment. That's going to be covered in the next video. If I click here, put a circle. If I put an X here, ooh, what's the circle going to do? You know what they're going to do? They're very tricky. Put an X here. Oh, circle can't do anything now because if I block here, I press it here, and look how cool that animation looks. It is so awesome. But I can't press any more pieces because it's no longer playing. I can't do anything. What am I meant to do? Game is over now. Whether I've won or whether I've lost, I should be able to retry or go back to the main menu, and we'll be handling that very, very soon. So this has been it just for finishing off the grid. If you have any questions, feel free to post them on my education platform, sonarlearning.co.uk. If you want to check out the source code, feel free. There will be a GitHub link provided. And as usual, thank you for watching, and I hope you have a great day.